I kind of rushed at the end of that one because I was running out of time on the other video, so I want to make sure that we're on the same page. So if we look here, the rate of change, or the change in y, was plus 3 compared to plus 1, and then plus 4 compared to plus 1. So the change in x stayed the same, but the change in y changed, so that's not steady or constant, so that's why this does not represent a linear function. So I want y'all to pause the video and try to do this one completely on your own to determine whether this is a linear function or not. So pause the video, and when you unpause the video, I'll have the answer up here, but make sure you try it by yourself first. If we look here, we saw that this was going up by 5 when this went up by 4. Y went up by 5 when x went up by 4. So both times y went up by 5 and x went up by 4. So that is linear. Yay! It is linear because the change in y corresponded with the change in x, and it was constant or steady. It was the same between each one. So that is awesome. So now we know how to determine whether it's linear by looking at the graph or by looking at the table or the points. So now we need to be able to look at a linear function and determine from the equation if this is linear. So our last way is here. So this is one of the most important things that we're going to do all day on Monday. This is like the hardest part to really grasp. The other stuff was pretty easy. Now, this is called the standard form of an equation, and it is written ax plus by equals c. This is so super duper important, and I know we've never talked about anything like this before, so you just need to think about this, and we're going to come up with a way where we can memorize this standard form. A standard form of the equation, ax plus by equals c, and this only works when b is not 0. So it can't work if b is 0, because then you don't have any y. So this works when b is not 0. So if I can write my equation in this standard form, then it is linear, as long as b is not 0, and we can determine what a, b, and c are. So we're going to go ahead and change these. These are not in linear form. We're going to change them in the linear form. So I'm going to draw my equal sign. How do I change 4x minus 7 equals y into this form? Well, I need to take away minus 4x then on both sides. To get rid of positive 4x, I subtract 4x on both sides. Minus 4x on both sides. So now I can write this equation again. It's going to say now 4x minus 4x canceled. I'm left with 7 on this side. Y minus 4x. Those aren't like terms, so we can't combine them. So I can just write this as negative 4x plus y equals 7. So negative 4x plus y equals 7. So now it is in standard form. We have negative 4 times x plus, well, what number would we plug in here? 1. Good. So negative 4 times x plus 1 times y equals 7. So my a value is negative 4, because a times x. My b value, the coefficient of y is 1. And my c value is 7. So this is in linear. This is a linear function. That means if I graph this, this would be a straight line, and it would be a function because I can write it in the standard form of an equation. So I know that was fast, but I wanted to make sure you got some examples so you could start to think about it. So I'm going to have you pause the video and try to set both of these two equations up in standard form. So ax plus by equals c, and then tell me whether they are linear or not. Remember, if you can get them in this form, ax plus by equals c, then it is linear. So pause the video right now. So here are the answers. So hopefully you got this right. The second one can be written in linear form. I subtracted 5x and I have it written in linear form here. So a is negative 5, b is 3, and c is negative 0.5. This last one cannot be written in linear form. The reason it cannot be written in linear form is because you have negative 3x squared. If you have x squared, I can't write it as ax. It would have to be ax squared, and that is not standard form. So this one has an exponent. It cannot be written in linear form. So this one is not linear. You don't need to fill that table out. Okay, so if we look here, these are the example problems that I want you to work, and I will put the answers up on the Edmodo. Please work these on your own, and I will put the answers up. Thank you. See you all tomorrow.